a comprehensive study of basically when to use the sine law and cosine law. Now I have derived these two, and these are for the acute triangle here. So I'm going to put up a link up above to the sine law if you want to review it before you watch this. And also you probably should kind of know the cosine law as well. And if you want to know where it comes from, I'll put up another link up above there. In this video, I'm going to basically tell you when do you use which one. So now for convenience, so what I have done is I have labeled, so I have these vertices here, A, B, and C. And I'm going to actually take the angles and I'm going to refer to the angles. So instead of writing this would have been angle A, I just simply will write A. And I'm going to do the same thing for all the other angles at the vertices. Now the other component is you'll notice that I have written out the small a, b, and c. So these, so this b, this a, this c, these are on the opposite side of the angle. So notice that here, so the opposite of that c is basically that's angle C is the side of it. Okay, I'm going to utilize the small letter c. And now the same thing, so the opposite of the angle A is going to be this small little a, and that's again going to be the side length. And I'll do the same thing for the B. Now that you kind of get an idea of what these A, B, and C's are, the sine and cosine laws, so here I have rewritten them. Again, you can kind of go back if you want to know where they come from. This is the sine law. So it compares basically as a ratio of angles to your sides. And you'll notice that you can write it in two different ways. Sometimes people write the sine of A, sine of B, sine of C on top on the numerator, or you can take the reciprocal of everything and then your actual sides is written on top and then the angles, okay, are written at the bottom. Now, the cosine law, which I have right here, so for this cosine law, now I have written it for every single side. So for example, a squared, b squared, and then c squared, so you'll see that. But in reality, you really just need one. And once you have the one, doesn't matter how you label your sides or your angles. Now, one thing that I will note, so from here, so for example, I'll take the first one right here. If, for example, you actually know what all the sides are, so A, B, and C, then notice that you can actually isolate and solve for your angle, or actually for any angle for that matter, because if you know all your sides. And if you do that, you will notice that the cosine, so for example, of whatever angle you choose, in this case I'm choosing A, is going to be nothing else but simply, so it's going to be a squared if you move over the other terms, so b squared minus c squared, and then you can divide by negative 2bc. Now, we don't really like to have this negative in here, so what we do is we change the signs of these to get rid of that negative. And for that matter, so this is exactly the same thing. So this looks a little bit nicer and cleaner. So we write it in this way. So notice the signs changed there because that negative, which we had at the bottom, okay, basically we utilized to divide into the numerator. So that's what you would have there. And notice, so the angle that you want is basically going to be, okay, so the way to remember it is that it attaches to that side or the length of that side A that you have in that formula. So those are your sine and cosine laws. So nothing strange as of yet. But now the question is, when do you use them, or when can you use them? Can we find a pattern? Now, in any triangle, so what you have is, you know that utilizing these equations or these formulas, you're going to have to know at least three pieces of information. So you're either going to have to know two angles and a side, or two sides and an angle, okay, or all three sides, or all three angles. So that's going to be the minimum amount of information you need. But now, do all of those pieces of information actually allow us to use the sine law or the cosine law to find something of interest? And the answer is it's not always the case. So what I'm going to do is I'm going to just show you, and then I'm going to summarize for you when can you use these and when can you not. So I've created this table. Now, don't get overwhelmed. I'll explain this. So obviously you see A, B, and C. So those are the lengths of the sides. And then you see capital A, capital B, and capital C. So they're just repeating all the way down. And those are the angles, the capitals. And then on the right-hand side, there's a sine, and then there's a cosine. So on the right-hand side, the sine and cosine just simply means, can you use the sine law or can you use the cosine law if the highlighted pieces of information in that particular row are given. So for example, in the first one, what you have is, if you have A, B, and C, so if you know the lengths of each side, can you actually use the sine law or cosine law? Well, it turns out that you cannot use the sine law, but you can use the cosine law. The cosine law you're going to be able to find, basically, to find any angle that you want. And that would have been from that piece of information. But unfortunately, for the sine, if somebody gives you all the sides, that's great. However, notice that in those pieces of information, so if I know A, if I know B, and I know C, and I do not know any of the angles, then the sine law is useless. It doesn't help us at all, because we can't actually find out any of the angles just by knowing the sides. We can, however, use the cosine law when we know all of the different sides to find any angle that we like. So what I've done here is, so I've highlighted the pieces of information that you know. Now, basically we have 6 pieces, right? We have 3 sides and then we have 3 angles. So if you're given 3 of them, so out of the 6, there's actually 20 different ways that you can give 3 pieces of information. It's kind of 6 choose 3 problem. And what I've done here on the right-hand side is I started going through and basically asking myself, all right, so if somebody gives me these row by row, when can I use the sine law? And then when can I use the cosine law? And then can I find a pattern? And I'm going to summarize the pattern because the pattern is actually pretty easy to be able to extract once you do this exercise. You can do it for yourself as well. So for example, I'll go through a couple of them, and then I'm going to show you the summary so that it gives you a comprehensive idea of when can you use a sine law and when can you use a cosine law. So in the second row, so if I have 2 sides, so side A and side B given, and then I have an angle which is the angle A, then it turns out that I can actually use the sine law. And in that case, what I would have been able to use is so I have A given. Notice that your angle A is also given. And then what I have is I have B given, but I do not have my angle of the B. So I had these 3 pieces of information given. And notice, out of these 3 pieces, of course, I can now solve for B. So I can use the sine law to find my angle B. But that's about it. That's all that I could find. Now, in the next row, so now I have, again, sides A and B given, and now I have B, the angle B given, and nothing else. Well, so if you look at this, and you can kind of play this game back and forth, it's a little boring. However, it's a good exercise to force you to see, okay, what can I solve for? So in this case, I can actually solve for the angle A, and that is it. I cannot use the cosine law for this, just as I could not use the cosine law for the previous row. And the reason for that is because in the cosine law, one of the key assumptions is, so 1, if all 3 sides are given, then sure, you can find any angle using the cosine law. But in the other case, the only time you will notice that you will always have to have at least two sides given. So all of these, the sides might be given as you have it, but the angle that you need is actually always the opposite angle of the side that you are looking for. That's what you want to be able to find. So as you walk through this and you do this exercise for yourself, so I have actually done it right here for each and single combination of any three pieces of information, and you notice on the right hand side that sometimes you can use the cosine law and sometimes you can use the sine law. Now, is there any pattern? Now, the first pattern that I want to show you is when you cannot use anything at all. So for instance, this happens right here. So if I take, okay, so if I keep scrolling, I notice, okay, that I could not use the sine law or the cosine law here. I could not use the sine law or the cosine law here. And I cannot use it right here. And then finally, I could not use it right here. So what's the pattern in all of these situations? You'll notice that the pattern for all of these is that what happens is that you have two angles given. So in all of these, the two angles were given, and one of the sides was given. However, the side that has always been given in all of these situations, at least the first three, is the side which is basically adjacent to the two angles. So if you would draw that out for yourself, so let me add, so I'm going to just add an extra page in here to be able to show you, okay, when is it not possible? So this happens, okay, so if you take a triangle, any triangle like that, and you have two angles which are given. So now it doesn't matter which two angles. So those are, let's say, the two angles. If you have this, which is the adjacent to both of the angles, that side, which touches the two angles, then the sine law or the cosine law cannot be used. That is the key that you will find from this pattern. And again, so it does not matter, which angles you choose. You can choose any angles that you want. But as soon as you notice that the side that is given is actually attached to the two angles, it's the adjacent one to them, then all of a sudden, I can't use the sine or the cosine law, and I'm stuck. I can't really find anything else. So that's what happens. And that's the nice kind of study that you can do when you're doing these kind of combinations between them. The last one that you'll notice is that all the angles were given. And of course, you might know all the angles, which is great, but just knowing the angles is not going to give you any opportunity to figure out what any of the sides is. And it doesn't matter if it's sine law or cosine law. Again, you're stuck. All right? So that's the first summary pattern that I have for you. This is when you cannot use the sine law or the cosine law for anything. All right? Now, what about the other patterns? What do I see in terms of all of the patterns that I have if I just wanted to see when is the sine law being able to use that? So if I go through all of these, so I can kind of scan through and I can see, all right, so I can use the sine law here. I can use the sine law here and here. And then, I see these sine laws are popping out over here. So definitely more than the cosine law. So all of these, so I have all of these right here. And now I look at the pattern between them. Okay. So what do I notice about the pattern between all of these? What you will notice is that for the sine law, you have always the angle and then the opposite side given, and one other piece of information. So if I scroll up here, so notice that what I have is, I always have the actual side and the angle. So the angle and then the opposite side is always given in all of these. So notice Here it's B and the angle B. Here it is A and the angle A. Here it is the C and then the angle C. And then, I can continue this, okay, all the way throughout, but I think you can notice the pattern. So that's what happens. And then one more other piece of information is given. And then whatever other piece of information is given, if it's a side, another side, then you can always find the opposite angle. If it's an angle that's given, then you can find the opposite side. So that is kind of the summary that you have for the sine law. So here, what I've done is I've kind of summarized this in terms of the sine law that you see there. So for the sine law, you will always have an angle and then the corresponding side, meaning the opposite side, okay, that is given. So it is either going to be the angle A and then the side A. It is going to be either the angle B and then the side B, or the angle C and then the side C. So that has to be given, plus one other side or angle. That's when you will be able to use the sine law. Now, what about the cosine law? Can we find a pattern there? So for the cosine law, so if I have this, I'm going to switch this to, let's say, green. So first I noticed that, well, if all the sides are given, it's kind of the best situation, because then I can actually use this right here to always find any angle that I like. And you can label the angles and sides as you wish. So that is number one. Now, all the other cases that you run into, so let's say this is the cosine, here is a cosine, here is the cosine, and that's about it. So those are the possibilities that we have. So what do we notice there in all of those situations? What you should notice is that in all of those cases, at least two sides are given, and then the angle of the missing side is given as well. And if that's the case, then you can use the cosine law. So for instance, so notice that right here, what we have, so we have A and B, so those are the two sides, and then the angle of the missing side is given, which is the angle C. The next one, notice that I have A and C right there, which are given. And then the missing side, there, that angle is given as well. And you can see that pattern all the way throughout. So in summary, so for the cosine law, so what you have is either all three sides are given. Great, I can then find any angle that I like. Or an angle with two adjacent sides is given. Right? So meaning two sides, and then the missing side's angle is given. So what I mean by that is, if these two sides are given, so if this side is given, so this side is given, then this angle must be given so that you can find this side. And of course, you can do that for any two sides that you want. So it can be these two, but if these two are given, then you need this angle so that you can find this side. All right, and then you can do that for the last one. So that is basically the summary of the sine law and cosine law. So it's good to know when you can and when you cannot actually use them. And this is a little bit of a comprehensive idea, so that if you are going to be applying it in grade 10 to some applications, you can start doing and then see for yourself, all right, which one am I going to use, sine law or cosine law? Or maybe I just can't apply them at all. And please remember that you cannot apply them when you have either all the angles given, or you have two angles given and then only one side which is attached to the angles. If that happens, you cannot use the cosine or sine law. Thanks for watching. See you in a future video. Bye, everybody.